Hello, my name is Enzifago and my university ID is 2126466. Today I am explaining about the design of machine learning solution for biometric recognition task. So, at the first line, I have import the drive library which allow us to mount the Google Drive so we can access the file stored there. The second line mount the drive to the content drive directory so we can access file stored on the Google Drive. And here I have imported the OS library which allow us to work with the files and directories, and I have set dname variable to the name of the project file tr0 and unzip the file in the current directory. So in the next part I have import the listdr function from the OS library. The second line creates the list of all the images file in the tr0 directory, and in the third line of the code it will count the number of images files and assign the result to the n variables and prints the output. Now in the next part I have import the image and pie plot function from the matplots. The second line of code it will read the first image line from the tr0 directory and assign the result to the m1 variables, and at last it will print the size of the first image in pixels. And now I have create the data and target for the training and ANN, and the data will be the matrix of n equals to 1500 rows and as multiplied w columns, where n is the number of image and s equals to 77 and w equals to 68 are the weight and width of height and width of an image in pixels. The target will be the n matrix here. And by using the numpy arrays for saving the matrices, I have saved the data and target file. Now I have the yellow classify image file. Here I have used the training and testing approach to split the data. And at the first, I have mounted the Google Drive for collapse and load two NPI files containing the data and label for the facial image dataset. After that, I have import the functions from the scikit-learn learn machine learning libraries, including train test split, classification, PCA, and MLP classifiers. And now I have split the dataset into the training and testing sets using the train test split function with 30% of the data reserved for testings. And after that, principal component analysis PCA is applied to the training and testing image to reduce the dimensionality of the data. The number of PCA is set by the number print component parameter, which can be optimized through experiment. And after the PCA, a neural network classifier is trained on the transform training in data using the MLP classifier. The number of hidden neuron in the neural network is set by the NOH parameters, and I have used the solver Adam activation ReLU with a batch size of 256, Borvus true and early stopping true. And at last, I have used the train classifier to make the predicting on the testing set and print the classification report. And finally, it calculates both training and testing sets and print them. Now in k-fold validation, in the same way as a previous file, at first I have mount the drive and load the data and target files, and I have also load the necessary functions like train test split, classification report, PCA, MLP, and matplots here. And after that, PCA is applied to the training and testing image to reduce the dimensionality of the image data, and here I have set the PCA parameter to 200 to reduce the dimension of the image to 200. And after PCA, a neural network classifier is trained on a transform training data using the MLP classifier functions, and here I have set the hidden number of hidden neurons 300 with the solver Adam activation ReLU and batch size 256, Borvus true and early stopping true. And after this, finally, to get an estimate of how well the neural network will generate to the new data, cross validation is used to evaluate the model accuracy on multiple subset of data. Here, k-fold cross validation is being used where the data is split into k subset and the model is trained and evaluated k times on different subset of the data. And here it prints the accuracy score of the each fold, and it also print the mean accuracy score across all fold, and it will also print the accuracy score for the training set and print the accuracy score for the validation set. I have separated the training set and the validation set here. And at last, the result for the validation score is plotted on chart to visualize the accuracy of the model. Thank you.